Neural network basics. AI beginner level. Introduction. Artificial intelligence systems today can recognize faces, understand speech, recommend movies, and even generate human-like text. Many of these capabilities are powered by neural networks. Neural networks are one of the most important technologies in modern artificial intelligence and machine learning. They are inspired by the human brain, where billions of neurons communicate with each other to process information. Artificial neural networks imitate this idea using mathematical models and algorithms. They allow computers to learn patterns from data and make intelligent predictions. Examples of neural network applications include image recognition, voice assistance, language translation, recommendation systems, spam detection. Understanding neural network basics is the first step toward learning deep learning and modern AI systems. What is a neural network? A neural network is a machine learning model made of interconnected units called neurons. These artificial neurons process data and pass information to other neurons. In simple words, neural network equals a system of connected neurons that learns patterns from data. Example concept. Input data means neural network means prediction. The network learns by adjusting internal parameters during training. Inspiration from the human brain. Neural networks are inspired by how the human brain works. The human brain contains billions of neurons connected by synapses. Example concept. Neuron receives signal means processes signal means sends output. Artificial neural networks mimic this idea. Each artificial neuron receives inputs, performs a calculation, produces an output. Although artificial neurons are much simpler than biological neurons, the concept is similar. Artificial neuron. An artificial neuron is the smallest unit of a neural network. It performs three main steps: receives inputs, applies weights and bias, produces an output. Example concept. Inputs means calculation means output. Each neuron combines the input values and passes the result to the next layer. Neural network layers. Neural networks are organized into layers of neurons. The main layers include input layer, hidden layer, output layer. Example structure. Input layer means hidden layer means output layer. Each layer processes the information and sends it forward through the network. Input layer. The input layer receives the raw data. Examples of input data: image pixels, audio signals, numerical data, text features. Example concept. Image pixels means input layer. The input layer passes the data to hidden layers. Hidden layer. Hidden layers perform pattern detection and feature learning. Each neuron performs mathematical operations on the inputs. Example concept. Input means hidden layers detect patterns means output. Neural networks may contain one or many hidden layers. Networks with many hidden layers are called deep neural networks. Output layer. The output layer produces the final result of the network. Examples: cat versus dog classification, spam versus non-spam email, house price prediction. Example concept. Neural network means predicted result. Weights and bias. Neural networks use weights and biases to control how information flows. Weights. Weights determine the importance of each input. Example concept. Input times weight means contribution to output. If a weight is large, the input has more influence. Bias. Bias allows the model to shift the output. Example concept. Weighted input plus bias means neuron output. Bias helps the model learn more flexible patterns. Activation function. After calculating weighted inputs, neurons apply an activation function. Activation functions decide whether a neuron should activate. Example concept. Neuron calculation means activation function means output signal. Common activation functions include ReLU, sigmoid, tanh, softmax. Activation functions help neural networks learn complex patterns. How neural networks learn. Neural networks learn through a process called training. Training involves feeding input data, generating predictions, comparing predictions with real answers, adjusting weights. Example concept. Prediction means error, calculation means weight update. This process gradually improves the model's accuracy. Training data. Neural networks learn using training data. Training data contains input features, correct answers, labels. Example dataset. Image means label. Cat image means cat. Dog image means dog. The network learns patterns from these examples. Loss function. A loss function measures how incorrect the model prediction is. Example concept. Actual value versus predicted value means loss. Lower loss means better predictions. Common loss functions include mean squared error, cross entropy loss, backpropagation. Backpropagation is the method used to improve neural networks during training. Example concept. Prediction. Down pointing arrow. Calculate error. Down pointing arrow. Send error backward. Down pointing arrow. Update weights. This allows the model to gradually learn the correct patterns. Simple neural network workflow. A typical neural network workflow looks like this. Dataset. Down pointing arrow. Input layer. Down pointing arrow. Hidden layers learn patterns. Down pointing arrow. Output layer prediction. Down pointing arrow. Error calculation. Down pointing arrow. Weight update. This cycle repeats many times during training. Real-world applications. Neural networks power many technologies. Image recognition. Identifying objects in photos. Speech recognition. Voice assistants understanding speech. Recommendation systems. Suggesting movies, products, or music. Medical diagnosis. Detecting diseases from medical images. Autonomous vehicles. Self-driving cars detecting objects in roads. Advantages of neural networks. Neural networks provide several benefits. Advantages include learn complex patterns, handle large datasets, adaptable to many problems, high accuracy for many tasks. Example concept. Large data plus neural networks means powerful predictions. Limitations of neural networks. Despite their strengths, neural networks have limitations. Limitations include require large datasets, need powerful hardware, training can be time-consuming, difficult to interpret decisions. Example concept. Complex models means harder to explain predictions. Example Python code. Beginner example. A simple neural network can be created using Python and TensorFlow. Import TensorFlow as TF. From TensorFlow, Keras import layers. Model equals TF, Keras, sequential. Layers, dense. 16. Activation equals ReLU. Layers, dense. 1. Model, compile. Optimizer equals Atom. Loss equals MSE. This creates a simple neural network for prediction tasks. Concepts learned from neural networks. Understanding neural network basics helps learners understand. Checkmark how machines learn patterns from data. Checkmark how modern AI systems make predictions. Checkmark how deep learning models are structured. Checkmark how images, speech, and text are processed by AI. Checkmark how advanced AI technologies are built. Neural networks are the foundation of modern deep learning systems. Simple definition. Neural network. A machine learning model made of layers of artificial neurons that learn patterns from data and make predictions. Final summary. Neural networks are one of the most important technologies in artificial intelligence. Inspired by the human brain, they consist of layers of interconnected artificial neurons that process and learn from data. Through training, weight adjustment, and backpropagation. Neural networks can detect patterns and generate predictions. Because of their ability to learn complex relationships, neural networks power many modern AI systems, including image recognition, speech assistance, and recommendation systems. Learning neural network basics is essential for anyone starting in machine learning, deep learning, and artificial intelligence.